Hi, Hannah. Welcome to the Genetic Genius podcast. I'm so thrilled to have you here today.
Me as well. Thanks, Dr. Lulu. I appreciate you having me.
Yeah, I'm so excited. Of course, as being the genetic genius, I love to talk anything about genetics. And sometimes I don't always have every show is not just about genetics because there's not that much out there in the world. So I always get super excited when I do have a guest on like yourself, where I can really dive into the good stuff, so to speak, the cellular impact. So before we dive into talking about the world of DNA, I'd love for you to introduce yourself, Hannah. Tell a little bit about your background so the listeners can get to know you a little bit better.
Yes, definitely. Thank you for this opportunity. My name's Hannah Went. I'm actually from a really small town north of Dayton, Ohio, but moved to Lexington, Kentucky for college at UK, University of Kentucky, and originally wanted to be a veterinarian, actually. So I studied some animal science for my first couple of years of undergrad, did some really fun labs with large animals, but actually ended up just switching to a general biology degree, trying to pursue the career of being a genetic counselor, which I'm sure obviously you're very familiar with, and maybe your listeners as well. Ended up taking a pretty unique position right after college. They convinced me not to go back to school. So I stayed at this really innovative pharmacy where we specialized in bringing new peptide pharmaceutical products to the cash pay integrative healthcare space market. And really, after a couple of years there, we always realized peptides made people feel better and look better, maybe increase libido. They could actually feel those effects, but the scientific literature was very far few and in between. So we wanted a way to quantify the effectiveness of those peptides and other offerings at the pharmacy. And that's where I actually got started in the epigenetic space, or really the biological aging space, using those epigenetic DNA methylation markers. So instead of waiting for 40-year longitudinal trials, we could do it with a test right there and then with a 2-week turnaround.
That's great. Oh, I love peptides. I've had a couple guests on talking about peptides, which they're so cool. I think that's definitely something new, just DNA, new on our forefront of health, which is so fascinating. And thank you for sharing your story with us, because it's always good to know what brought you here today, because we all have such an amazing background when it comes to, I don't know, there's just, especially as women, I feel like the world is open to us for exploring all different opportunities. And it's really fun to hear the paths that we all take.
Yeah, definitely. I'm always curious in what people spend most of their time doing, right? What they do on a day-to-day basis, how they've grown to where they are now. So again, thank you for allowing me to share a little bit of my story.
Of course, Hannah. So let's dive into talking about epigenetics. But first, we'd love to talk about the concept of biological age, because I think this is a piece that people are so excited about, including myself, in helping people turn back the clock, so to speak. How does a biological age really differ from chronological age?
Yes, let's just define those terms. I know this seems intuitive and it's very simple, but let's just lay the framework in the groundwork, because it's essential to understand this. Your chronological age, or your calendar age, you may hear it referred to as, is just going to be how many years you've been alive, right? Your birth date, how many candles you're blowing off, or out, I should say, on top of your birthday cake. Whereas this idea of biological age is where we have almost the secondary age that is a result of your underlying cellular biology. So how your cells are aging, how you're aging at a cellular level. And we know that we are aging at a biological level that's different from people of our same chronological age, with the term phenotypic variation. And that's just basically saying, hey, if you go back to a high school graduation and you look around, not everyone looks the same, right? Some people who are your same age look 20 years older. Some people who are your same age look 20 years younger. That's the idea of biological age. And really, Dr. Lulu, we'll get into this, I'm sure, but biological age can be measured a ton of different ways. A little fun fact I like to give people when introducing them to this topic is, way back in the day, they used to measure people's biological age by how many cigarettes they smoked, or how many pack years they had, which is a really crude measurement.
Thank God we don't use that one anymore.
Exactly. And again, we know smoking's negative for that biological aging aspect, but we know there are better ways to measure it.
Right. Yes. And there's lots of companies out there that are doing biological age testing, which is really fascinating. And I love that it's a really great way for patients to see inside their health. And just as DNA and epigenetic testing is, it allows us to see the inside, what's going on. Because we on a day-to-day basis, just like you're saying, it's hard for us to realize how we're improving, right? We're like,
Yeah.
okay, like today I did this, maybe I went for a run, maybe I had a great green shake, but how did that really affect myself? Where am I improving or not improving?
Yeah, I couldn't agree more. We make these mini promises or these non-negotiables to ourselves, but it's really hard to track. Life gets busy. I really encourage people when they're doing the epigenetic methylation testing, the biological age before and after, to keep a journal, write down what you're doing. That way you know what's affecting it. Or there's certain apps and stuff where you can track your daily habits. But the before and after testing is a true reflection of everything you've done, whether you've been tracking it or not. So usually when I get into more of those like biohacker based conversations, I say, hey, we can't manage it without measuring it. So we need a quantifiable way to do that. And of course, that's that quote by Peter Drucker, I'm sure you've heard before.
Yes. And I think that the piece that's really important about what you said there is a way to measure it. And I think that's what we're really moving forward in science and technology. And that's the biohacking piece, like you said, but a way for us to also, it empowers us as an individual when it comes to our health, because we're seeing like, oh, cool, I can really see what I'm doing makes a difference. Like I personally just gave up caffeine this week. I'm still here on the planet. But I've been tracking like with some things I've been doing to see, okay, how was my body responding in a caffeine state? And now how am I doing in a non-caffeine or a low caffeine state? So it's fascinating. I love it.
Yeah, it really is. And unlike genetics, which is obviously not going to be changeable unless you're doing some gene editing or some really intense stuff, you are in control more with those epigenetics. So a lot of those quotes and things that we see on social media, like you're not your DNA or you are what you eat and DNA is not your destiny. You get the point. Things like that. That's actually true. Like you said, it's power to us. We're in the driver's seat if we want to be, if we want to take that control. We're no longer this passerby in our own life. We really have the control on how our genes are expressed. And I think that's super powerful.
Oh, yes, me too. I love it. Okay. So someone is looking to learn more about their biological age, and what are the kind of some of the key factors? You talked about the difference, or you defined chronological age and biological, but what are some of the key factors we're looking at when we're really diving deep into learning about our biological age?
Yeah, first and foremost, there's a lot of different offerings out there. You really want to look at algorithms that have been publicly validated, publicly validated and published, same thing. So the reason that is so important is because we want to relate it to outcomes, right? We want to relate this to outcomes because if you get an age back, and that's all fine and dandy and cool, but we need to be able to say, okay, how do we change it? How do we reverse our risk? Myself, with my company, we've done a really large trial with Harvard where we just created what we call our omic M age, which is going to be the best in class biological age predictor. It's really exciting. But what we're actually able to tell you from that is your risk of COPD, type 2 diabetes, heart disease, death. I think there are 7 in total. I'm forgetting a couple of them off the top of my head. And using different clinical variables, we were able to create that biological age score. So not only are we able to say this is your biological age, but we're also able to say, check your HbA1c or your creatinine or your hemoglobin. And if you decrease or increase these couple markers over here and over here, we can see a positive reflection in your biological age, which will reduce your risk. So that's the end goal, because a lot of people are going to do N of 1 self-experimentation with this testing, which is great. That's what it's really used for. But we do have an idea of what changes it according to those interventional clinical trials. And we need to know which clocks are being applied to those and which are most useful.
Yeah. And I love how you brought in the piece of the actual like lab data, because I think that's a huge piece where it is a marker in time, like in the moment in time, right? We're saying like, okay, what is my blood work saying today? When we can see that, but what it doesn't, when we're looking at it in basis to the chronological or biological age, it differs, right? Because and like you said, what is our impact of that in basis of our death, the end of life piece of time.
Yeah. So actually with that new testing that I just described to you, we're able to give you those clinical measurements by just looking at your epigenetic data. We truly believe that epigenetics is the future. It's the future biomarker. We're undergoing
Right.
this epigenetic revolution,
Yeah,
right? So
totally.
we can give you not only biological age using those epigenetics, but clinical markers, proteomic values, metabolomic values. We can tell you how much you've smoked or drank across your entire lifetime. And I know not everyone wants to know that, but those are just some of the implications.
Right, which is amazing, right? That's what gives us great data. And because it allows us from the preventative health point, what measures do we need to take to change that impact, right? Let's say you had a crazy party age in your 20s and you were drinking and smoking a lot. Then what are you going to do now to have the best health moving forward? Maybe you want to make sure you're looking at your liver. How's your liver functioning? How are your lungs? Do you need to do a lot more biohacking techniques to get yourself back on track?
Yeah, no, definitively. And there's some really exciting work that we'll be doing here soon where we have even these systems aging clocks. So we're able to break down, I think it's 11 different systems, like the age of your liver, the biological age of your brain, of your heart. So like you said, Dr. Lily, you can say, oh, my liver is maybe aging a little bit more fast. I need to take preventative approaches, or, it can be lifestyle, supplements, medication, procedural based therapy to reverse that, because that's causing the overall system damage of the entire body. It's just so fun. I've learned so much. Really only been in this space, opened my company TruDiagnostic in 2020 in July. So yeah, just like 3 years basically. And there's just been a plethora of research, and it's so fun to chat about.
Oh, so fascinating. And it's really the future of health, I think. Really all of this different information that we can use to see a complete different aspect of our health, and I think that we're gonna, I hope, see a huge change in our health moving forward.
Yeah, I think so too. I know you mentioned, Dr. Lulu, oh, if we had those crazy like party years, that is reflective in your biological age, because your methylome, your epigenetic signature is really good at picking those things up. One of the algorithms we have as well, I'm not sure if you've ever heard about it, is called the Dunedin pace of aging.
No.
Yeah, I think it's worth talking about if that's okay.
Totally. Of course.
It separates your past with what you're doing right now. So it tells you how quickly you're aging biologically for every one chronological year. So it's like a speedometer.
Yeah, totally.
It's really cool.
Super cool.
Yeah, the range is 0.6 to 1.4. 1 is the even mark. 0.6, you're aging 40% of the way slower. 1.4, you're aging 40% of the way faster. And that was created from a study that took place in Dunedin, New Zealand. That's why it's called that weird name. But it's a really interesting study. And I would say world-class, first of its kind, kind of gold standard for both a clinical and research setting.
Oh, that's fascinating. And is there a piece of this particular aspect of research that tests how stress plays a factor in, maybe that's how we're going to dive into talking about epigenetics, how stress plays a role in our biological and chronological age?
Yeah, definitively. I would say it's one of the biggest factors. There's a really large psychosocial kind of analytical aspect of stress and biological aging. So there's actually a paper, it's a really good one, by Dr. Jesse Poganik out of Harvard. The title of it, I believe, is called Biological Age is Increased with Stressors and then Restored Upon Recovery. So we do see biological age increase, and then we see it actually go back to baseline or even before baseline. And the stressors that he looked in his paper are going to be a little bit more extreme COVID-19 diagnosis, also pregnancy and surgeries. The people who had unelected surgeries had worse biological ages compared to the elected, which makes sense. So we know, I guess, besides that paper, chronic stress is going to have a much more larger effect compared to your acute stress. But any type of internal or external stimuli, any type of stressor is definitely going to make that clock tick a little bit faster.
That's right. That's totally right. So let's talk about epigenetics. Let's dive into this piece, because I think we almost jumped ahead of it, which is fine.
Yeah, no worries.
Right. We're like, boom. So can you help us provide or explain it, like an overview of epigenetics, what it is, break it down? I talk about it all the time in the show, but there's always new listeners, and I think everybody's still trying to understand it, right? So what is it exactly, and how it influences our genetic expression? Because I think that's the big piece there.
Exactly. Setting up this framework again. I get so excited. I get ahead of myself. So yes, epigenetics. Epi is actually a Greek prefix. It means above. So when you see the word epigenetics, just break it down. Epi, we're looking above the genome or those genetic markers. And remember, genetics is your nucleotides, your A's, T's, C's, and G's. Those aren't going to change. You got 50% from mom, 50% from dad. Those are stagnant. What happens though is looking above the genome, these are just going to be considered different modifications to the DNA. So how can the DNA actually change? One example I like to give is, think of a computer. The hardware in the computer is going to be your genetics, whereas the software is going to be the epigenetics. The software it's telling the hardware what to do and how to perform. So that's, I think, a really good definition of epigenetics in particular. There are a lot of different modifications. The one that we're going to be mostly chatting about today is going to be DNA methylation. So when we say this, and we can dive into this further too, a lot of your listeners are probably familiar with the MTHFR gene, or I'm sure you've discussed that before. DNA methylation gets a bad rap because of that gene. But all that means is if something is methylated, that gene is turned off. That's all it means. If it's unmethylated, it's turned on. And we want a really nice, healthy balance of things that are turned on and things that are turned off, because we want our cancer genes, oncogenes turned off, tumor suppressor genes turned on. So that's just a nice example as well.
Yeah, that's great. Great way to explain it. And it's true. I think the MTHFR gene has given methylation a little bit of a bad rap. Oh my God. So it's good to know that and I think that's an important piece, is that our body has lots of different ways it methylates, right? And so it's a key component of DNA and a key component of how our body functions within optimal health. Yeah, very great. And I love how you broke down epigenetics. That was a really wonderful way to understand the hard drive and the software, because we can change, right? How our epigenetics is not altered, quote unquote, but affected. So it is altered. We can alter it in that way, but I think it's like from the place of how are we going to change that software? What are we going to do with our nutrition? What are we going to do with our stress? What are we going to do with our water? What are we going to do with exercise to then make the biggest impact on our, as you said, on our hardware?
Yeah. No, exactly right. Some people you'll see this kind of description a lot too. Some people like to think of it as like a light switch with your epigenetics.
Yeah.
I almost I like to think of it more as like a light dimmer, because it's not binary. It's not like it's all the way turned on and all the way turned off. There's going to be like a nice medium. You can be somewhere in the middle. You could be like 3/4 of the way. So yeah, think of it like a little light dimmer too.
Right. The mood lighting.
Yeah, exactly.
Yes. DNA mood lighting. I love it. I love it. So when we're talking about epigenetics, and so this really differs from the term genetics, because that's really important for listeners to understand. And why is this understanding, or this distinction of understanding, like so crucial for the impact when we're talking about the context of aging and health?
Yeah. So the idea, I think we have to start off with talking about aging as a disease, really.
Right. Yeah,
I think this is, where it all got started. This is pretty controversial. Some people think aging is a disease. Some people don't, because disease has a negative connotation. And as you become older, you gain a lot of wisdom, a lot of life experience. I don't think that context really matters. What matters is if we're able to call it a disease and then get a lot of FDA approved, maybe prescriptions or things to actually reverse this process, or a lot more grant funding is more of the positive side of that. So the idea being that age is the #1 risk factor for almost every single chronic disease and death. That's something we've known for hundreds and hundreds of years.
For eternity.
So really for eternity. That's not new. What's happening, and what I really counsel all of the healthcare providers I work with on, is aging is more of this kind of, how do I want to say it here? The initial phase, everything else is secondary. All of the diseases are secondary. Type 2 diabetes happens because you're aging at an accelerated rate. Same with cardiovascular based diseases, any type of metabolic disease. So aging is a primary issue. As you're aging, as your biological age increases, your risk of those diseases, those secondary issues increase as well. It became really interesting because we were like, okay, let's be able to quantify that. And that's where that epigenetic methylation testing comes in. There, again, are a ton of ways you can measure biological aging, but from a platform standpoint, epigenetics looks to be the best from precision, accuracy, sensitivity level. It's also going to be the cheapest. You just need a little small blood sample, blood spot card, and it's going to give you more insights too. So it's going to be a really good surrogate marker for almost anything else in the body.
Yeah, that's great. And I love the piece when it comes to genetic testing. It's not very invasive, right? It's very it's very easy for someone to do a test. They don't have, it can be expensive. Some of the genetic testing can be expensive. It's all over the board. We see from ranges from $900 or $99 to like thousands of dollars, right? It really depends on the company. But I think that's one piece about testing, is to look for a company that is reputable, that has a good reputation. and also it fits your pocketbook, but then also about looking to see what is the data that you're going to, or the data you're going to get out of it. I think that's an
Yeah.
important piece because a lot of the information has changed
Yeah.
from 23andMe, right? That's so outdated at this point of time.
Yeah.
Because you don't really get any information. I like to see how the diet is, how the nutrition, how the exercise is, all the components is really important to me as a physician, because I want to be able to help my patient the most, and the patient doesn't need all the pages and pages of all the genetic data, of all the
Yeah.
SNPs. They just don't even understand it. I mean, it's
Yeah.
like very complicated. So I think that when we're learning about the distinction of epigenetics and genetics, we want to understand, let's talk about SNPs. I'd love for you to explain that because I just mentioned it. What is the SNP part of genetic testing? And that would be a great place for us to talk about too, I think.
Yeah, exactly. So that SNP part, and I'm sure just reiterating and echoing what you said, that's a single nucleotide polymorphism. So it's basically going to be the variant of that particular gene that you have. And there are a lot of these. That's why we're all different. That's why we respond better to different dietary plans or stress or sleep and fitness levels, all sorts of different things.
Yeah.
You're exactly right, Dr. Lulu. I think both are helpful when I'm, again, counseling a lot of my healthcare providers on like packages or whatnot to provide with their patients. I will be the first person to tell you I'm obsessed with epigenetics, but I think you need the genetic makeup too. So if you use genetic testing and epigenetics together and marry both of those, if you optimize your genes, you're only going to get better epigenetic outcomes as well. So I think it's important to know your genetic blueprint. But again, I'm the type of person who wants to know everything about myself.
Yes, I think that's important for people to know and have that distinction for sure, and be able to understand what they're looking for in the information, like what's their outcome, what's their goal, and then working with a practitioner who's knowledgeable about DNAs that can help them to transcribe it, to understand it. It's not, you can't just read over one of the documents and understand your DNA in an hour.
Yeah.
Like, it's much more in depth about that for sure. There was something I was going to ask you and then it slipped out of my brain. So I'm sure it will come back in just a moment.
You'll remember it.
Yeah,
but again, agree on all fronts. I think you as an individual are very unique. Treat your body like that, right? Treat your genes like that. Treat your epigenomic factors like that, and really learn what works best for you. Some people, I don't know, wake up at 6 a.m. Some people need to wake up at 9 a.m., right? Like how much sleep you need and whatnot. But it can get very personalized. And I think that is a necessity if you want to optimize your health.
Right. And that's the individualized aspect of genetic health that is so important and so like up and coming, because that's the piece where we really want to, where medicine has been so cookie cutter. Right. So, okay, everybody with, like you mentioned before, like diabetes, everybody with diabetes take this pharmaceutical blank.
Yep.
I'm like, but that it rules out so many other factors that could be coming in that could be changing your actual outcome. Right. And so I think that's the light bulb that a lot of listeners and people around the world are experiencing. Oh, right. There's lots of different things that my body may need. I'm totally a unique individual when it comes to health.
Yeah, for sure. And we can get into the healthcare system, right? We are in if you want to go down that route, we're in a sick care model, right? People just want to treat you when you're sick. So again, that's where this aging testing really makes a difference. And if anyone's listening and you're even younger than 20 years old, but especially if you're between 20 and 30 years old, go get your epigenetic testing done now. Because if you have aging that is accelerated, you are going to be able to change it easier now than you are going to be in a couple of years, even just 6 months.
Yeah, exactly.
Yeah. Because most of the people we test at my company are between 40 to 60 years old. We've tested about 30,000 people. Guess when disease diagnosis skyrockets? Between your 40s and 60s.
Right, yeah,
so
totally.
No one really has that cohort of the younger generation in their epigenetic test. But that's where you get into more of the healthcare system weeds, because they don't want you to identify disease early, right? They want to put you on all these medications and charge you. But if you can identify that and say, oh, I have an increased risk for type 2 diabetes. Let me optimize my insulin levels and insulin sensitivity. Let me make better lifestyle and dietary choices. And then you can retest 6 months later, and then your risk can be gone. Like those are the insights that we can see that are actually tangible and takeaways from this type of epigenetic reporting.
Yeah, that's so important. I love that you brought that up. And I did remember what my question was.
Yay!
Brain turned on, activate caffeine.
Oh yeah. Oh no.
Yeah, no, it's fine. So a lot of people have the old belief, and I'd love you to bust this kind of belief, that if you have a specific marker, that means that you're going to get this disease. So let's say, for instance, you have a BRCA marker, breast cancer marker, then you're like, this is it. It's your fate that you're going to get this particular outcome.
Yeah. Yeah.
Yeah.
So you're talking more about like that hereditary based component and factor. So
Right.
you know your genetic code, you know that you have your increased risk. That is stagnant. But what you are in control of is that epigenetic code. So you can make lifestyle changes. Yes, supplement, medication. I always urge people to start with lifestyle if you can, to really break your code. Epigenetics is a tool to break your code and optimize your lifestyles. For example, this is a really fun term and topic to talk about. It's called epigenetic transgenerational inheritance. So it's a mouthful.
Right.
But basically, this means that we can even pick up signatures from our mother and our grandmother. And we, if you're having children, if you have children, you can pass on those signatures to your daughter, to your son, so forth, grandchildren and whatnot.
Right.
So if we're doing the best that we can for our body, it's only going to pay off further and further for our offspring, because there is a little bit of a hereditary component with those epigenetic markers. But again, most of it, over half of it, is going to be in your control.
Yes, which is great news, listeners. Yes.
Breaking news.
Breaking news. Yes, tuning in. Yeah, because I think that's people, when I have patients come in and I'm talking to them about getting their genetic report or epigenetic report run, there's a fear factor that comes up, right?
Oh, yeah.
Oh, I don't want to know. I don't want my data to be out there. There's all these different pieces. So I'd love for you also to talk about that, is that fear factor. How can we break through this barrier to help more people want to do testing, because to let them know that it's so much further on the other side of health.
Yeah.
It's way more beyond that.
It really is. So there's 3 points I maybe want to add there regarding like privacy policy, terms and conditions. Where does my data go? Number 1, your genes aren't changeable. If you have a raw genetic file, we can track who that belongs to if we have a piece of their DNA.
It's like your blueprint.
Exactly. It's your blueprint. That is your code that belongs to you. And that can be scary for a lot of people, I should say. And that's totally reasonable and understandable.
Yeah.
With epigenetics, it is changeable. Remember, that is the key. So if you have a raw file, they're called IDAT files here. If you have a raw IDAT file, that can never, ever be tracked to the same person, because your methylation markers they're stable enough that they're not going to change every second, but they will change over time. So you cannot track that back. Number 2, so this is more of like the sample processing. When we receive your sample, we take it through intake. So we check it in our proprietary laboratory information management system. We extract the DNA and then we quantify it. And then that 4th step is we actually take it through a bisulfite conversion. That's the definition of that is really where we denature the DNA to highlight the methylated cytosine positions. And when you do that, it's a really harsh process. It's not pretty. You break your DNA. So once you do that, you can never go back to your original DNA strand. So that's just a part in the process that helps us with privacy. And my last one is we are a CLIA certified lab located in Lexington, Kentucky. We follow HIPAA, all those different rules, CLIA CAP certified. We're checking all of those boxes. With your physical sample, the blood spot card or blood tube, whatever you send us, legally, we have to keep it on file at the building for up to 6 months after we receive it. Then we're allowed to discard it appropriately. We're really covering all areas. I think the take home and the key takeaway here is that methylation is changeable, genetics is not. So trackable and untrackable in terms of getting back to the individual.
Yes, exactly. Thank you, Hannah, for breaking that down, because I think it's really important for people to understand the empowering piece of testing instead of the fear factor of testing. I think that, because we need to move forward in our health. And that's the only way that we can break through it is to let go of some of that fear. So what was some of the inspiration behind founding TruDiagnostics? How did you really say, okay, this is what I didn't want to do to make a difference in the field of epigenetics?
Yeah. Oh, that's such a great question. Again, I honestly have to go back to the pharmacy to start with, just because there's a lot of negative connotation around the peptides because they're not FDA approved. So we were trying to prove a very strong point to the FDA that these peptides are literally saving people's lives. So I wanted to change basically the policy, you could say, right? I just had such hope and trust in these products that I really wanted to prove it. That's how it first started. Actually, a couple months after we were trying to do that for the peptide products, we ended up selling that pharmacy and just focusing on TruDiagnostic. And when we made that switch, the one thing we set out to do was sell the best biological age test to our healthcare provider network in that integrated functional medicine space. I think now it's changed dramatically over the past 3 months. We launched the company right before COVID, which was probably the worst timing ever, but we're doing fine now. But I would say now I really want to create the best in class, affordable biomarker testing through using the Epigenetic platform. And again, I want to make it cheap. I want to make it affordable and usable for everyone and anyone. Do I think insurance will cover it at any point soon? No, probably not. But do I want to make it cheap enough for anyone who can spend a couple extra bucks and put it in their budget out of pocket? Yes. And I think it is doable. Like you were hinting on years ago, genetic testing just used to be $1,000, $1,500. Now it's $99 less than 24 hours and you can get your whole genetic code. So it will get cheaper as time goes on. But I think moving forward, I'm really set on more of the research. We do a lot of academic-based partnerships and university-based partnerships and act as their sole provider for processing the sample since we have the lab. But just the interest we've gotten in research collaboration, like our IP portfolio has really taken off. And I think that's really exciting too.
Oh yeah, totally. Thank you for sharing that. And the field is so exciting. I can see your excitement behind it and I can't wait to see. And I love that you are also inspired for making it affordable, right? Because I think I've had some other testing companies on about DNA testing and that piece where it comes to affordability, because then you can have all of your family members, right? It's like you want when you're excited, don't you want to know this data? It can help change your life.
Exactly. Yeah. A lot of partners will take this test together and compete for their aging or around Christmas time. It's like the gift of turning back the clock, and a lot of people purchase for family members. Yeah, I think we'll see a big movement towards this test. One thing I want to say TruDiagnostic really holds ourselves accountable for is being the most scientifically validated epigenetic testing company as well. So we really want to make sure we're science backed. We don't want to sell you any supplement or medication or anything. We just want to provide you with the testing, but we'll guide you on what literature is out there on proving to reverse it.
Yeah.
That's, I think, really, when you think of like more of an identity, that's really who TruDiagnostic is providing that best testing.
That's great. Yeah, because there are a lot of other pieces with other companies doing that out there. So that's true. What did you learn about, what was the most fascinating thing you learned about from your epigenetics testing and like this light bulb? You're like, oh my gosh, is there one thing that really stands out for your own individual testing, if you don't mind sharing?
Yeah. Oh, in terms of like my biological testing when I've done it. Okay. Gotcha. Yes. That I am way too stressed out, but I guess that's not like a surprise because I think it's something that I've known. But no, something I've learned, I guess more on a serious note, is you have to do the N of 1 experimentation with yourself. Something that's worked really well for me to slow down my deneen pace, and actually the really, I would say, number one proof of concept interventional trial that's been shown to do this based on the literature and research is going to be caloric restriction. So not necessarily intermittent fasting or time restricted feeding, which is just that window, because you could set a window of even 2 hours and eat 10,000 calories for the next 2 hours.
Yes, you can.
I know that's extreme, but you get my point. Just eating less. And that's really worked well for my body. That's worked well to slow down my pace of aging. And I think there's certain ways you could perform caloric restriction too. I just eat less, but you can do things like a water fast, could perform intermittent fasting or time restricted feeding, but making sure you're eating less. That usually helps people eat less anyways. Or you could do things like Prolon, like the 5-day fasting mimicking diet. So there are a couple options there to maybe help guide you if, it's harder for you, but you definitely want to consult with, your healthcare provider if you want to perform caloric restriction. We don't want you to be pregnant or breastfeeding. And we definitely don't want you to be an athlete as well if you're trying to meet some type of muscle mass goal or some type of goal.
Yes, exactly. Thank you for sharing that, because I think it's really fascinating to see how you yourself have used the testing to help elevate your own health. Thank you for sharing. Like, you understand that you're stressed out, right? Yes. So you probably have learned all of the lifestyle techniques and components that help you to reduce that stress, I'm sure.
Yeah, definitely. One thing that I've done before and after too that's worked really was like hot yoga. That's a really good stress reduction. Again, for me, my body, my epigenetic results. But again, I'm the type of person that needs to be like sprinting on a treadmill, like sweating to feel like I've had a workout.
Me too.
But it's, probably something with our genetics.
Exactly.
Kind of being in that room and being more mindful and processing your thoughts and stuff has
Mhm.
worked very well for me too. That's a recommendation I really like. In breath work, there's an
Mhm.
app called Othership that's really good. So
Othership.
I like doing that app too.
That sounds
Yeah.
cool. I haven't seen that one. I'll have to check that one out. I'm a
Yeah.
total geek when it comes to technology. So I love checking out new apps.
Yeah, yeah, it's great. They have like every day I think every week they have a longer session you can do. That's 30 minutes to an hour, but then they have an up and then they have a down. So the up
Mm,
is getting you up in the morning, do some more enlightenment work. That's not the right word, but, and then for the down, it's like more about sleeping and putting you into
right.
more of a relaxed state. So it's pretty
Yeah.
cool.
Yeah. I get parasympathetic and sympathetic state.
Yes.
Yeah.
Yes.
Yeah. Yeah. That's great. I love that because that's a really important part of breath work. So cool.
Yeah.
So cool.
Yeah.
Yeah. And let's talk about the piece with methylation array-based diagnostics, because you mentioned it a little bit. So let's talk about more kind of how that contributes to life extension and preventive healthcare. If you can talk a little bit more kind of like of what that means, what it does, and how it really is playing that piece in that puzzle of life extension.
Yeah, yeah. I'm trying to think of a really good example. I'll go with a company that we're getting ready to partner with soon. I won't name them, but I'll tell you what they do. So
Okay, great.
there's a lot of work in women's health in
Yes.
epigenetics, like fertility, especially, but a lot of work in preconception and postconception. So what this company is actually doing is they're creating a marker for basically preterm birth and
Mhm.
then postpartum depression, all from your
Mm,
epigenetics.
mm.
So while mom is pregnant, she can take the epigenetic methylation test, the array-based diagnostic test, and we can tell her if she has an increased chance into what extent of depression.
Mm.
And then same with short-term birth as well. Excuse me, preterm birth. So
Preterm birth.
knowing those risks and then being able to say, oh, wow, I have a 98% chance of getting PD. I need to start going to things like hot yoga, or I
Mhm.
need to start going to, I don't know, some type of classes. I'm sure
Right.
there's something out there
Yeah.
where you can actually lower that. And then same for preterm birth. There are some things that you can do that may help you have a better labor and delivery process.
Exactly.
That's where we're going. That's the preventative kind of part of this epigenetic methylation testing. And again, that's just like one example out of thousands.
That's so cool. I love that.
Yeah.
Yeah.
Yeah. It's just super fascinating. And again, it's right now, this is interesting too. Right now with epigenetics, it's hard to say, do this and you'll see this change because it's
Right.
so new.
Yeah.
Where we know that with genetics, like the research is out there with genetics in terms of optimizing those genes, it will get to a point, probably, I would say hopefully the next 5 years, I would say the
Right.
next decade,
That's what I was going to say is
where
5 years.
exactly, yeah, where
Mhm.
I can say, take this and you will get this result. Take
Right.
this and you will get this result based on your epigenetics. So we have an idea now, which again is really exciting,
Yeah.
but it can be as equally as frustrating just because this field is so new. I'm looking forward to that. But that's a small example of how this ties into preventative medicine. We have a lot of other markers too, but I think that's a good one because those are real life examples from
Mhm.
researchers that were able to make it clinically applicable.
Right. Oh, yeah. Great example. And we're already seeing in my practice, I can see when I'm using genetic reports and epigenetic reports of patients and saying, okay, let's look at your report and let's see if we can use this supplement to see if we can make some changes. I can already see that happening on my end with in my practice. So I just need the other side of the field
Yeah.
to catch up. Right.
Yeah,
Yeah. Which we
exactly.
will.
It acts as a good proxy to the people who are doing everything, right? Like they're have a great exercise regimen, they're eating, they're low stress, they're happy, they are taking all the supplements, medications, and doing things like hyperbaric oxygen chamber therapy and red light therapy. There's a point where that is way too much. So being able to look
Right.
at like more of an epigenetic level, because doing all of those things can cause a lot of inflammation, oxidative stress, cascading negative effect on the body. So
Yeah.
sometimes we find that, yeah, those people who are really more or less like obsessive over all of that can have like negative effects actually too.
There's a fine line of balance.
They're everything in moderation.
Yes, everything we do when we go to extreme, even with like in that biohacking field, like you were just mentioning,
Yeah.
it can cause things to go on the way other side. We have to bring things back and rein it in and feel like what's that fine balance, because we want everything to be in balance for our health all our genes on
Exactly.
and off. Exactly. The dimming switch, as you mentioned.
Yeah.
Dimming.
Yeah.
Yes. I think we got to hashtag that somehow.
I know I usually talk about, someone actually told me this. I honestly forget who it is now, but you want to shift your methylation markers in your favor, right? You don't
Yeah,
want
right.
everything turned on
Exactly.
or turned off, but we're shifting everything. And again, it's not going to be perfect. We're all human, but
What?
learn what you're willing to give up,
Yes.
and like the caffeine,
Right.
and learn what you're
Exactly.
not going to give up, and just make it your lifestyle. Don't beat yourself up about it, but keep
Right.
those promises to yourself too.
Yeah, that's an important point, Hannah, because I think it's true. Know what you're able to change. When you see that
Yeah.
report coming out, you're like, oh, maybe I can change this. Or for me, I'm always experimenting. And that's how I talk to my patients about it. Hey, why don't you try this? See what happens, right?
Yeah.
And keep track of it in your body. Notice what happens. How's your body feel? Do you notice anything? Do a good trial for yourself, like 90 days, because we need those red blood cells to shift and change. But I think that empowers us when we can see when there's with ourselves, we take our own health into our own hands and we can see, we feel the change. We
Exactly.
feel the change.
Put it together perfectly. No, that's a great
Yeah.
explanation. Mhm.
So you mentioned to Hannah about the trials that TruDiagnostics has done, and how have these kind of given you and TruDiagnostics the understanding of epigenetic methylation, like the changes in their impact? Like, what is that knowledge? Because I think there's a little bit of a gray area. I don't know when it comes to clinical trials because it's biased, right?
Yeah.
There's so much information out there. So how did this information of the clinical trials help TruDiagnostics to have the right data?
Yeah, that's an interesting question. With epigenetics, obviously, the more people, bigger sample size, the better. We'll do really small pilot studies, but everything we do from an institutional review board study has to be like a clinical, has to be approved by that IRB, or again, a clinical trial.
Okay.
So the bigger the sample size, obviously, the better. The more data points they're getting, like more clinical values, like if they're doing a CBC, if they're, I don't know, doing metabolomic testing, proteomic based testing, like the more allergy testing,
Right.
whatever, the more they're able to give us, the more we're able to draw those like connections and make different prediction models, which is again part of the end goal here. And then I would say also we absolutely have to make it as controlled as possible for the IRB that we go through too. We do like to have people of all ages. We like to have men. We like to have women. A lot of times it's very disappointing, but you'll see a lot of the studies done in like less than 10 men who are very unhealthy, and they do that so they can see the largest reversal, which is just, it doesn't do anything for anyone. It's very
No,
unfortunate.
that's
Yeah.
not good.
Yeah, because they're going to be the easiest to change in terms of aging outcomes. But then I would say from a bioinformatics perspective, what we do is we run all of the aging algorithms on them. So our entire suite, and we're able to find different correlations and connections with the different therapies. The second part that I think is the most interesting and would love to hear your thoughts on too, because of your genetic background, is we look at the DMR, so the differentiated methylated regions. And that basically means, okay, at a genetic level, which genes are turned off at baseline and then are turned on, or vice versa, which genes are actually being effective by this intervention. And once we identify that, we basically know the mechanism of action that intervention is taking, which gives us a lot of insight.
Yeah, that's fascinating.
It's pretty cool.
Yeah, that's super cool, because I think that's the whole really like key when I'm working with patients and they're wanting to know about explaining to them, first of all, like what their impact is going to be on their health when they do genetic testing and epigenetic testing. But then when we can actually see that intervention start to come into play for turning on and off genes, that's really like the future impact of health. Because if we have something that we're really wanting to change for our biological health, how can we do that if we don't know what how the intervention is going to work?
Exactly. And then even from, again, more of a, I don't know, research and development type of level, if you have a medication that affects this gene, and maybe it's like a gene involving glucocorticoid levels or outcomes and affecting cortisol, maybe you could have that same effect by just doing something that lowers your stress level from a lifestyle perspective too.
Exactly.
So,
maybe just meditating.
Exactly. So then you can change strategies, but again, still needing that data is huge for this field.
Yeah. Oh, great. I love that your company, TruDiagnostics, is doing some of that really great research and clinical trial work, because it's really needed. There's not a lot of it being done out there. And this is the only way that our field can really be recognized as having an evidence-based background, and for people to
Yeah.
really understand, like, yeah, this is the science. It's the science meets like fun and spirit and then great nutrition and all of it together. Cause I love that part of it is it really gives us information, but it really helps us. It's like science meets health, but in a different way.
Yeah, for sure. We do a couple types of clinical trials as well too. We'll do purely interventional ones where supplement companies approach us and they want to validate their supplement. Then they can make age reversal claims on their supplement. And we'll even vouch for them as well because we know it was a truly great clinically designed study. There's some that do, different dietary approaches and see which group is better before and after as well. It's really fun. It's really exciting.
Yes. So I love it. Tell us about your exciting podcast, Everything Epigenetics.
Yes.
Tell us about that. What inspired you to start your own podcast? What kind of amazing things are you doing on it?
Yes. Thanks, Dr. Lulu, for giving me again an opportunity to share my platform.
Yes.
So Everything Epigenetics was actually an idea that's been around with TruDiagnostic for a couple of years. The education is very much lacking in this space. We wanted to use it as a way to talk to people to get the conversation going about epigenetics and what it means to our health. With all things, everyone got super busy. So we pushed that to the side, never created it. And I said, you know what? I want to make this mine. I'll put in the time, I'll put in the effort outside the 9 to 5 and sit, because I'm having these conversations daily, twice a day, 3 times a day with experts in this field. So I wanted to be able to bring that to listeners who are interested in to really break it down on an individual level of, hey, how can epigenetics affect your health? Hopefully for the better. We talk about things that are detrimental as well. Like we talked about the stress earlier. I usually am not interviewing, it's still a conversation, but speaking with researchers to bring their research to light because a lot of times it doesn't get much press. So yeah, you can check it out, everythingepigenetics.com. Would love to chat with anyone as well if you have any questions too.
Awesome. We'll make sure we'll put that link in the show notes because it's a wonderful field for you're diving into, and I can see your passion.
Yeah.
I can't wait to check it out myself. So excited. And as we wrap up some things today, Hannah, tell us about, do you have any like practical advice for our listeners? Like how can they better understand and apply the concepts of epigenetics or epigenetic human transformation to enhance their own well-being and longevity?
Yeah, epigenetics is everywhere.
Everywhere.
It really is. Your environment. If you have like more plants in your house, that actually increases your epigenetic aging for the better. How you talk to yourself, right? You can beat yourself up and have these like that bad internal monologue. Or if you say, you know what, it's okay, we'll get better next time. So even that actually affects your epigenetics. So just think about it one day, one time. Think about kind of your surroundings, your habits, who you're surrounding yourself with. Do you have quality relationships? All of those things are turning genes on or off, and hopefully a positive, but it could be a negative direction. And again, just making it your lifestyle. So I think it's a fascinating subject, and it's only going to get more and more targeted into what you can do to have better outcomes.
Oh, yes. Thank you for sharing that because it's true. And you can do little tiny things. Like you said, just plants. I have a plant in I have tons of plants in my house. I love plants. But yeah,
Me too.
Yeah, I love that. A friend of mine told me that you should have a plant every 10 feet for, yeah. So I was like, okay, great. I had no problem like making that a part of my environment, but they're so helpful in so many ways, of course, in helping us with detoxification and breath work, or breathing, not breath work, but breathing, but just being friends. They have such a good vibe.
Yeah, they really do. I know all of these papers coming out about green space. It's my excuse to go buy more plant. Hey, I'm not complaining.
You're like, sign me up.
Yeah.
Yes. Hannah, one last question as we wrap up today. If you had an unlimited budget, what would you do to have the biggest impact on the health and welfare of our planet?
Oh, if I had the biggest budget, what would I do? I would make sure that everyone on the planet, if I had an unlimited budget, was fed, had proper nutrition, hygiene, a roof over their head. Everyone, anyone and everyone. Doesn't matter who you are, where you came from.
I love that. That's great.
Yeah.
Ding. You get that one. That was
Woo!
a fabulous one. Yes. Yeah. So tell us how people can find you, a website. You talked about the Everything Epigenetics and how they can follow you on social media.
Yep. My Instagram is Everything Epigenetics as well. Twitter is going to be everything epi, EPI. And then you can see my company at TruDiagnostic.com, TRU. Diagnostic is singular, but yeah, my DMs are open. Feel free to message me. You can leave me the contact form on my website too, or email me as well.
Thank you so much, Hannah, for coming on today. I really loved our conversation. I can't wait to share it with all our listeners.
Awesome. Thanks, Dr. Lulu.